Hello, my name is Jaromir. I'm a Premier Field Engineer from Microsoft, and welcome to my session called WSLab Data Center Simulation Scenarios. This session was in Cloud and Data Center Conference Germany. Unfortunately, it was not recorded because some malfunction of device that was supposed to record all the session. Therefore, I decided to record it again. There is a special thanks to partners that made this conference possible. The conference was really great. I have to say it was one of the best conferences I've ever been. It was big enough, but there are so many people that were presenting their stuff, like AWS, Thomas Kren. I was able to see the service. I was able to do a talk with partners about their solution, and I was really impressed how Karsten was organizing it. So if you can, please join us because it was amazing. So thanks to all sponsors. Um, and let me introduce myself. If you don't know me, I'm a PFE at Microsoft now for 7 years. I'm from Prague, Czech Republic. I authored WSLab some times ago, it's already 4 years when I started. And I also wrote a workshop. Now it's called Azure Stack HCI Storage. It's a Premier workshop. So if you have Premier hours, you can pay for me, and I can deliver the workshop or any of my colleagues who is accredited to do so. I also have some kids, so it's funny how big family I do have. On the pictures you can see 4 horses, 3 kids, a dog. On the pictures there are not the cats. So yeah, I'm tired sometimes. So anyway, what is the purpose of this session? It's WSLab and what it can do. Traditionally, what you can see on the left, these are traditional labs, home labs, I would say, where Jan Tore has his heating, I would say, in the basement. It has 1.5 kilowatts. It provides heating to his living room and kitchen, from what he told to me. And also Roman Sere, he has his rack inside the bathroom, so it's kind of funny. I would like to include that. You still can have these kind of labs, but if your wife would be unhappy, that you probably have to do and figure out something else. So you can run WSLab also inside a laptop, not only big and bulky laptops, but also small laptops like Surface Pro 2. Like you can see on the right, there are multiple VMs, like most of them are saved, but the ones that are running are 4-node S2D cluster with SCVMM that's running on a DC. And as you can see on the screenshot on the right, there's actually SCVMM console with cluster, and there are 5 servers. One of these is actual virtual machine manager, which is also the DC. This WS lab is running on a Surface Pro, as I said. This Surface Pro has 8 gigabytes of memory and 256 gigabyte hard drive. So WSLab, what it is, where you can find it on aka.ms/WSLab, or if you just Bing WSLab, it should be, depending on the region and your preferences, it should be one of the first hits. So you can find the slides here already. If you navigate there's a folder called slides. You can find the slides, the scripts from this session and also from other sessions I had on the Cloud and Data Center Conference in Germany. And also there's one session I had on MVP days. So about the scenarios, what it is, it's usually everything is done from, I call, management machine. So we will today demonstrate that I'm managing everything from the Windows 10 machine, and also something I'll do from the DC with Datacenter installed. So you're not going to the machines, right? You never have to log into the machine directly using either console or RDP. Actually, RDP is disabled on the machines, right? All the scenarios do respect the best practices. Like everything is done with a PowerShell and everything is done remotely. So the PowerShell is actually running on your machine and it's using either SimSession or invoke command to send the command remotely to the remote machine. You can find a lot of scenarios in the folder called scenarios. Just navigate to WSLab on the first page. There's a scenarios folder. If you open it up, there's quite a lot of folders, and every folder contains scenario or even multiple scenarios. So there are some BitLocker scenarios where you enable BitLocker on S2D cluster, or you enable BitLocker on some remote machines. And then I here demonstrate on this BitLocker with GIA how you can, for example, enable BitLocker using GIA session. So you can restrict someone to control only a BitLocker feature. And in this scenario, I demonstrated you can have two kind of people. One is admin and one is just a reader who can check if BitLocker is enabled on all the machines, for example, in the enterprise. And this will be his only task and only permission he can do. I mean, only thing he can do on the remote machine when he logs in there. There is also certification authority, how to set it up, script it, including templates, and how to, for example, deploy it. I use this certification authority in multiple scenarios, multiple other scenarios like Windows Admin Center, like device guard, how to enable device guard, how to enable code integrity. There is also how to, exploring Windows Server 2019, like what are the new features in Windows Server 2019, like what new services, what new features, roles are there, and I'm just comparing it. So you basically spin up 2016 and 2019 servers, core, full servers, and you basically compare it with the PowerShell. So any of these scenarios you can spin and then continue exploring it, right? It's not limited just by what I wrote. You can do whatever you want. Like you can expand it, and if you think it should be there, you can pull it and you can contribute. So all of this I made available to everyone with the idea that everyone will be able to use it because it will be pretty easy, and if anyone would like to, they can also contribute. Even some scenarios that are not written by me, I think 2 or 3. Um, so yeah, there's quite a lot of stuff. Sometimes, actually today, users of WSLab ask me, hey, do you have anything with Hyper-V replica? Oh yeah, I do. It's in here. It's a rolling cluster upgrade, and there is a rolling cluster upgrade and Hyper, and it's not in 3 dots, right? But it's actually a Hyper-V replica. So there is, for example, 2012 R2 cluster, and not only one, there are 3 2012 R2 clusters, and I set up Hyper-V replica between them, and then I roll it to 2016. Then there is also how to run WSLab in Azure, so you can actually click and Azure machine will be generated. There's S2D converge, S2D hyperconverge, some S2D tools I use, like if you want to query the latency on the disks, what was the latency in the last hour, because there's a store port log, which is stored in every hour, which reports you how many IOPS were done on each disk and how many IOPS were, let's say, under 1 second, more than 2 seconds, 5 seconds. I don't remember correctly the numbers, right? But actually you can see if there is some disk which is failing, which in now 2019 is covered by the health service, by the way. And there are even more scenarios, right? So they're like S2D and, for example, in here, bare metal with SCVMM, where you can do bare metal installation with Virtual Machine Manager. You can do S2D and bulk VM creation, where you create multiple VMs with one single command, and these VMs can be domain joined, can have static IP address, can have multiple VLANs. So you basically define it in a hash table, and then you can just run a piece of script, and it will generate machines you want. You can again expand it. You can have multiple parameters, like I don't include there, like nested virtualization. If you want, you can just take a look in the script, modify a little bit, and you can create machines with CPU configured for it nested virtualization, right? Cluster sets, it's about cluster sets, right? You will set up multiple clusters and you will create a highly available namespace. You will create a management cluster. So it's pretty easy, again, as other scenarios. So a huge list, right? There are deep dives, for example, metadata deep dive, where you can learn how metadata works and how the quorum works in 2019. Pester, how it works, SCVMM in large data centers. Actually, what I will do today, I will demonstrate a few scenarios like S2D hyperconverged, S2D converged, some storage replica scenarios which are in here in other page. Let me just flip the slide. As storage replica folders, there are multiple scenarios in this folder, so it's like 4, I think. So and I will demonstrate how to do S2D to S2D storage replica. By the way, I often been asked that if we do have a stretch cluster that will do everything automatically. It's a good idea, I think, to have everything automatically, but if something happens, like something, you don't know what, right? Like you lose communication to one of your data centers. Would you like it to automatically flip, even if you don't know what's happening? I would prefer probably calling someone to the data center or someone who is nearby, just to understand what's happening, right? Maybe just someone did some unexpected reboot of the switch, right? Maybe someone did I don't know, some power outage, so just service restarted and it's now starting, and in 5 minutes it will be ready to go, right? So before flipping it, you maybe want to understand what actually happened, right? So, and then you can decide if you want to flip it, and if you want to continue with the disaster recovery, or if it's, for example, maybe the data center is on the fire, so you can say goodbye to it, right? And you need to flip as soon as possible. But maybe it was some human action that will be recovered in a few minutes. Okay, so this would be scenarios. So I have like 3 categories of scenarios. One is complex scenarios, where I do have lab config PS1, then there's also scenario PS1, and there's a README file where I usually do some description with the screenshots. But it's not like a lab guide. Lab guide is like a click next. This is like just a scenario PS1. The way you should use scenario PS1, I will demonstrate. It's actually you should load it up and take a look in there, what's there. There are regions, so you can collapse these regions, and then also you can just copy pieces of the code. You don't have to copy everything. This is not automation script, right? This is more or less like a documentation on steroids, where you can walk through the scripts and understand what steps are necessary to do, right? And it's in pretty dense way, so normally you would have to, for example, have documentation with the screenshots. But in this case, we have documentation with just a text file. It's a dense, right? It will tell you, this is my list of the computers, and I would like to install features to this list of the computers. And the features should be, I don't know, failover clustering, Hyper-V, and so on. In these complex scenarios, I have, for example, S2D hyperconverged, S2D converged, S2D and SCVMM bare metal, and even more. The complex scenarios usually do not have any guide. It's just too long, it's too complex. So the guide would be like, I don't know how many pages. So it's this S2D hyperconverged that simulates 2 to 16 nodes. It depends. If you want to have more nodes, just go to labconfig PS1, modify single digit number that you would like to have these 16 nodes. The time to deploy is around 30 minutes, maybe more. Just it's like, I don't know, to deploy the lab itself on the laptop, it's I don't know, 5 minutes, 7 minutes maybe. You have 4 nodes. Then you have to start it, wait a little bit time for machines to be started. Then you have to log in into the DC, and then you have to use the scenario PS1 code, which runs these 30 minutes. So together it can be like 45 maybe. But in 45 minutes you have complete solution, right? It's better to watch the script because sometimes it can fail. It's not fully automation script. It's not using anything like DSC. It's just, you know, step by step written in the PowerShell. It can run nested VMs depending what lab config configuration you'll choose. Now, too, there's one commented piece, so where you can just uncomment it, and in this configuration, you'll be able to see that nested virtualization is enabled, and also that the memory startup bytes is higher. It contains all the best practices. If not, just ping me, right? It does like a dedication for live migration for a network. I mean, not dedication, but it will limit, for example, the live migration speed, right? I'll do some calculations, so it's like 40% of the capacity. So if you have two 10 gig adapters, then it will be it's 20 gig, so half of so it will be 8 gig, right? Dedicated for live migration. Why 8 gig? Why 40%? Because I think if one of the adapters will be disconnected, then you will still not saturate this adapter that was left. Right. So if you it's for two adapters. So if you have four adapters, you may want to modify the script. So as I said, this is like an inspiration, can be used for the production. That's for sure. You can just use it for your servers if you want. It's complete. You just need to tweak up the on top of each scenario. You have to tweak up some variables. I will demonstrate it, right? If I'll not forget it. Okay, S to D converge. That's another complex scenario. It simulates 2 to 16 storage node of storage cluster and 2 to 64 compute nodes. It demonstrates scaling up from 4x4 to 5x5, and it's following the same as HCI. It's the same best practices as in HCI, because these are just two main scenarios I have here. So for example, like if you do volume deep dive, I do set up their storage spaces direct clusters, but these clusters are, let's say, just enable cluster S2D, right? I don't even enable Hyper-V there, because I just want to play with the volumes. Okay, let's take a look in the demo. So what I have here on my machine. So I have here a lot of machines in Hyper-V Manager, as you can see. So it contains 3 labs. One lab is complete, is this one. You can see it by prefix. This prefix is just, in my case, I renamed the prefix because by default it's just WSLab. I also add a version, so this is 2019.503, means this is the latest cumulative update. VMM, because VMM is installed there. And I also have VMM1 and VMM2, so I have 3 labs. In the first lab, I have 4 nodes that simulates hyperconverged cluster. There's nested virtualization enabled. Each node has 2 gigabytes of RAM. So when I will demonstrate later that there's already some cluster, you will see that it will throw some errors because, you know, in Windows Administrator, because there is not enough the memory. Of course, if you have more memory, you can specify more memory. But I designed this lab that it will consume roughly 64 gigabytes. So in my 64 gigabyte laptop, it will be running well. But this lab can also run in a laptop that has much less memory, right? You can tweak it. You don't have to run nested virtualization maybe. And also you don't have to run all the machines at once. My CPU is also really utilized, so I hope that voice will be recorded okay. Because sometimes if it's 100%, then the voice may be dropping. So let's see how it will look like. So this is my hyperconverged cluster. I also have converged cluster where I have compute nodes, and I also have storage nodes. All is managed, as I said, it's managed from the management machine. This one is Windows 10. Also, there is one cluster and second cluster in 2 sites. So there's like 2 nodes for S2D cluster and 2 nodes for other S2D cluster, which I also demonstrate, which is, I would say, storage cluster, right? So let me go back to the PowerPoints, and I will talk about another scenarios, which I call guided scenarios. These guided scenarios are, for example, all of these S2D and something. like S2D and Windows Admin Center. So in this scenario, it has some prerequisites. You have to, you know, set up, for example, 4-node cluster. Just paste this script, it will create a cluster, just simple one. And this one actually, yeah, this one has only these S2D clusters. And I guess I was not lazy and I wrote some guide, so you don't have to follow just a PowerShell. So you can blindly paste the prerequisites and then you can follow up the scenario, and you can configure um, in this case you can configure um, what's here actually. You will actually install Windows Admin Center. You will add S2D cluster into the Windows Admin Center. You will explore performance history in Windows 7 2019, and you will learn how to manage S2D cluster with GIA. Actually, you can only manage nodes with a GIA, right? So you will install role-based access remotely. In the case you have multiple clusters, you can run just a piece of code and it will push this to multiple clusters, so you don't have to go in GUI to every machine, and you can just specify this is my cluster, these are my nodes, and it will push it there. And then also you will learn how to add users for this airbag management. So these are these guided scenarios. There's also, for example, S2D and SCVMM, how to convert non-SCVMM installation to Virtual Machine Manager 1. It will create a logical network. It will convert switch to the logical switch. Then there's also S2D and SCVMM in large data centers. It will simulate 3 data centers. Each data center is located in different site. I have 3 sites. Each data center has 2 rooms. Each room has 2 aisles. Each aisle has 4 racks, and each rack is like 2 10 nodes clusters, right? So I was just kind of planning that this should be like a number of networks, and with this number of network, I was calculating the subnets. This was considering like 916 nodes in total, and I think Virtual Machine Manager latest limit is 1000 nodes. Also, bare metal deployment is pretty funny. You do bare metal deployment inside your laptop. We will also demonstrate this. And with this, I'll go to demo, or maybe I'll also demonstrate one other scenarios, because I told you that there are 3 kind of scenarios, right? The last one is I was lazy scenario. I was lazy scenario is just a scenario PS1 and lab config PS1, right? No description, nothing. So I have few of them, like storage replica. Some of the scenarios are I was lazy. So yeah, with this, let's take a look on the demo. Let's close the PowerPoint. Hopefully you are not sleeping, because PowerPoints are usually lazy, are usually boring. So let's take a look what we have, right? So I will connect to my management machine. As I said, this one is Windows 10 machine, and it to respect all the management best practices. So you have one machine dedicated for management. Let me bring down these windows so you know what's actually happening. So on the right, you can see that there are some scripts. These scripts are already available on WSLab page. So if I will navigate to WSLab, right, as you can see, this lab is internet enabled, so internet is there even if it's virtual machine. This virtual machine, let's take a look, is Windows 1903. So you can even hydrate latest and greatest Windows with a patch. So it's Windows 10, as I said. Let's go to the GitHub. In the GitHub, I will navigate to slides. And in the slides, I will go to CDC Germany. There are slides, PPT-Axis, and here are other files. And here are folders with each lab. So let me show you something. If I'll go to my folder here, these are my folders on my VM's disks. And if I'll go to one of these folder, there are firstly there's lab config, which contains the machines that should be created, and there are these demos I will have in this first lab, right? And there is also second folder, which is also a lab, and there is a script, scenario script, which I will also demo. So what I did, I use this lab config. If I'll open it, you will see that it's basically the same as on the GitHub. It will create a lot of machines. If you will deploy it, these machines will take like 13 minutes to deploy, so it's not a big deal. After you'll turn it on, you will grab these scripts, these scenario scripts. You will open it in PowerShell ISE like this. I prefer to close all of these windows because you don't need it here. And then what I do, I open up the PowerShell and I just paste it with the right click. So as you can see, this window, I think, this window should be S2D hyperconverged, I guess. Let's see. S2D hyperconverged, as you can see here. It looks crazy now, right? It's a huge script. If you don't want to read it, just hit Ctrl+M, and you will see that there are some regions, like region for the lab config, like region to install features, some basic setting on the servers. So let's open up the lab config. So this is what you can modify. So imagine you have a real systems and you would like to deploy it. So you can then say, I would like to have, I don't know, instead of 4 nodes, you would like to have 12 nodes, right? You maybe are using some prefix. So this is basically generating the names for my lab, right? Because it uses the prefix and then the number. And it will be generated like this, right? So it's here just because I was just lazy to, type all the names, and this is easier. So you can now copy it, and now you know how to generate the names, right? So you will be learning if you'll be reading the script. You can modify a cluster name, cluster updating role name. If you want to do, I don't know, disable CSV balancer, you can do this. If you don't like it for some reason. There's networking. You can specify the cluster IP address, storage network, storage VLAN, SRIOE. If the cluster IP is empty, it will not use static IP address. This is start IP for the storage net. So it can start with 1, or it can start with 10 or 100. If you have real hardware, this will configure VMQ. Dell hardware, it had recommendation. I have to check it, by the way, if it's still there. They recommended to increase hardware timeout to 10 seconds because of their Hitachi hard drives. Increase timeout for virtual environments. This is, for example, for virtual environments. For real environments, you don't want to have it. For virtual environments, if you have VHDs on a disk that has some latency, I don't know, it can be more than 30 seconds, and we don't want to drop it, right? PFC, iWarp, yeah. So depending on these switches, then you can go to code and take a look what's happening depending on these switches, right? So if you have like this configure VM or move VMQ out of CPU 0, so it will, there is a condition, if it's real VM or real hardware is true, then it will grab the switches that are external, and then in each switch it will grab all the adapters, and it will configure for each adapter that it will calculate also if you have hyperthreading or not. And if it's NUMA node 0, it will start on the different CPU, right? And you can deep dive into I don't know, how to configure cluster networks, right? How to rename it. So I'm renaming it to SCVMM management and so on. So this script run. This script run for, let's say, there are some errors, because I specify that I would like to configure Rocky. So it run, it installed Datacenter bridging and configured something, right? So this is a little bit crazy, but I also validate it. So if I run scripts to take a look where the PFC is enabled, and here you can see I was not able to apply some configuration because this is virtual environment, so I'm not able to configure my virtual network adapter. So this is expected, right? However, in the real environment, it would be probably unexpected. So yeah, it's better to, when you start with these scripts, it's better to just select a portion of the script and paste it and look, take a look on that, how it looks like, if something is happening or not. All right. So in the end, VMs fail to start because, as you saw in the beginning, every node here has 2 gigs of memory, so it's expected that the machines will not start. Let me open up the server manager, and in server manager, I will open up the failover cluster manager. In the failover cluster manager, I will add my cluster, my hyperconverged cluster. You can note that the failover cluster manager, when you open it up, it will recommend you to use Windows Admin Center. We will also use Windows Admin Center, don't worry. So this is just to demonstrate that all tools can be used to play with the WSLab, but also new tools can be used. So something is still visible only in the failover cluster manager, but I was talking with Cosmos yesterday, and he reassured me that it's just a matter of time, right? So here we go. Here's my S2D cluster. As you can see, it has witness configured. There are 2 subnets. There's current host server here. It's configured. You can see that witness. No. A file share witness is here. Performance history disk is online. These core infrastructure resources like SDDC management or health management are online. That's great. Let's take a look on the roles. In the roles, we will see that few VMs made it to run. These VMs are actually nano servers. They are pretty small. Yesterday I had a question from one of the people who were on my presentation, and I didn't mention that how to create this nano server and how to get it into the lab, right? So how to create it? You can open up your folder where you have parent disks, and in parent disk you have this create parent disk PS1. If you right click and run with PowerShell, it will guide you through creating whatever disk you want, like 2012 R2 or Windows 10 19H1 or even Nano server. If you provide 2016 server, it will ask you 2016 ISO file. It will ask you, do you want to create nano server? Because this is 2016. You will say yes. You will provide it. You will provide MSU packages. But there's one catch with MSU packages. I think it was February cumulative update that doesn't work. So you should probably use the latest is January that worked for the nano server. Or you don't have to use any, right? And then the size will be small. It's just operating system, it will run. Okay, so this is the way you would create your package. Then you can put it into the tools VHD before hydration, or you can just copy it with clipboard. You can copy it with clipboard when you will be asked. You'll be asked for it, that's for sure. Let me just demonstrate. If I'll just go here and go to lab config, I will collapse this region and I will copy it like this, and I will paste it into one of these, for example, this PowerShell, or I can just open up a new one just to not interfere with that one. Let me just right click. Right. So now it filled all the variables, and now it's asking and telling me, hey, please select the parent VHD. So yep, I will select the nano server that I have already in my tools disk, and as you can see, all variables are now populated. So right, so where is it? Now the VHD path is in the variable VHD path. So VHD path is now this one. My VHD is located on D drive, and then you can just continue and continue, right? Let's go back to the failover cluster manager. So my VMs are here. I also have my nodes. You can see that nodes have 4 domains configured, so you can see site and reg. This is very useful when the health service will kick in. It can provide you information about where the failure happened, in which reg, in which site, and what disk, right? How about storage? I have multiple disks created. As you can see, there's cluster performance history, and then mirror disk and mirror accelerated parity disk, just to demonstrate how to create mirror accelerated parity disk. As a pool is healthy, it will simulate, in this case, 200 terabytes of capacity, because each node has 12 disks, which each disk is 4 terabytes. Maybe I should update it, because now you probably will be buying 8 terabyte disks or even more. Right, there are networks configured. One is management and one is SMB. And from this view, you can already see that these are VNICs. So actually, there's one set switch, switch embedded team enabled switch, that where you have one management and multiple SMB adapters. You can see there's a storage subnet here. So this is pretty cool, isn't it? Okay. And then now you can practice like investigation. What's the problem with the cluster? So you can, shut down the node or remove the drive and take a look what will happen if you do and this and that. Because sometimes, or probably most of the times, you don't want to do that on your production. You cannot play with your production. Or if you don't have a real servers, then it's much easier to do it inside a lab, right? Especially if you can throw this lab away and just have it again in almost no time. Actually, I hydrated this lab at 9 a.m. and now it's 12:55. But in meanwhile, I was shopping. I was doing totally different stuff. Okay, so this is my hyperconverged cluster. So let's take a look on the second one. So this window I can close, and then I have another one. Oh, there's another window with a PowerShell, or is not? Oh, I closed it. Is it possible? No, this is the different machine, right? So let's see. Yeah, this is another window which is about my 4x4 cluster that I will expand to 5x5. So what I mean with the 4x4 and 5x5. So here I have a compute cluster, and if you'll take a look inside a compute cluster, what VMs I do have here, these are, by the way, fake VMs, because the only thing I need to prove is that I can access my configuration that is on the, let's go to settings, I'll show you. That is on the scale out file server now. So if I'll go here, you can see that configuration is located on scale-out file server. And in this case, this is not configuration, this is VHD, right? But the machine is located on the scale-out file server. So let's take a look what scale-out file server we do have. Connect to a cluster, browse, there's storage cluster, and I should be able to see that there's my scale-out file server role. I will be able to see my shares. By the way, this is 2019, and in 2019 you can do infrastructure scale-out file server. This is normal one, but you can also, with single command, enable infrastructure, and for every virtual disk you have there, or every volume you have there on the S2D, it will be automatically published as a file share. So it's also pretty awesome, but I'm demonstrating it this classical way. And again, everything is configured by the best practices. Here are the nodes. There's a storage. There are some disks, right? Oh, not here, right? Disks are actually in here, and a storage cluster. There are networks. You may notice that there is SMB and management, and both are public, because in scale-out file server you have to have cluster and client, right? In SMB network. And here you have also networks. Dedicated one is for SMB, so it's pretty cool. And let's do one thing. Let's expand this cluster by 2 more nodes. One for uh, compute and um, one for storage. Right. So scale out compute node. So what's here? Configure networking, blah blah blah. Ah, here it is. So if you collapse all the sections, then there is one part which is scale out S2D cluster and then scaled out compute cluster and add cluster node and then configure permissions and all of this stuff, and then you can create some VMs. So let me copy all of these steps and just let it run, right? And then we can take a look there what's actually happening and if it's running or not. So just uh, actually, I was in the session yesterday and I had my Xbox controller and I was demonstrating that it's so easy that you can do everything with my Xbox controller. So I was doing everything with the Xbox controller and deployment was happening when I was pressing my B button. B button was just a right click, so I just right click into the PowerShell window and it did actually this. So you are just watching the script, how it's running, and just controlling if anything is wrong. If something would be wrong, you would just pause it. You can pause the script by selecting something, just like this. And then you can just again continue. Okay, so there's also one thing. I already installed Windows Admin Center. I did it with a script again because it's much faster and much easier to document. So I have here somewhere, there's some bug probably in the full screen. I don't see the taskbar from here. So let me just flip it. Here you can see that I downloaded Windows Admin Center and then I installed it. Right. So actually, if I'll go now into my IE, into here, I should be able to see. Why not I'm not able to see it? Maybe because it timeouted because, right, I didn't choose my Windows Admin Center certificate. So this is actually the first time I'm logging in into the Windows Admin Center. Let me just again go full screen. Right. I probably cannot go full screen. I'll have to do it this way. Let me just make it bigger. My CPU is pretty utilized, so you're really burning your CPU if you are doing this. Next, okay, finish. This is my Windows Admin Center, the latest one. Actually, it probably tell me that there are some updates available. Not sure, but anyway, let me add a connection. Let me add hyperconverged cluster, and let me add S2D cluster. As I said, it's taken a little bit time because my CPU is a bit hammered, right? My memory is also a little bit hammered, so let's add S2D cluster, and hopefully it will be there. Okay, add it. Great. My cluster is added. When I open it up, it will connect to CDC management and it will show me some basic information. And then you can browse your cluster, you can play with your cluster, even if you don't have any hardware, just your laptop. And as I said, it doesn't have to be bulky laptop like mine. It can be whatever laptop like Surface Pro. Okay, it's now querying all information. As I said, it's now pretty slow because of all this utilization. Imagine that I'm running 1, 2, 3, 4, 5 clusters already on my laptop. It's a laptop machine, right? It's running 5 clusters. It's simulating all the crazy stuff you normally could not do, right? Oh, there's an update available for the extension. So let's update it, right? So I think this one is for the disk. So if you didn't see any disk metrics, just update. Extension. Yeah, there's one. Oh, it's Azure File Sync. Let's update. File Sync update. Right. So you can play with Windows Admin Center, and you will be able to see what actions are needed to do in your cluster. In my case, in this case, you will be able to see that your cluster is pretty overloaded, that the cluster is out of all the resources, that there's error that more than, I don't know, 50% of physical memory is consumed, and it exceeds the threshold. So there's a lot of information like that. You can see what is the storage usage. Total size 48 terabytes of the volumes used is 299 gigabytes only. You can see the performance history. As you can see, this cluster was just created today, and you can go and play with whatever you want now. Okay, let's go back to my Converge cluster and let's see what actually was happening. It's not so simple just clicking and adding the node as you would probably expect. You have to configure all of these things, like if you want to have kernel memory dump or active memory dump only, you may want to configure active memory dump. You may want to enable meltdown, spectre mitigations. You may want to install different roles, like for deduplication, BitLocker. It depends, right? Okay, so it will continue. So let's go to another one. So CI is already done. It will add the nodes, right? So we can go back there and validate if the node was added. Now we can go with S2D and SCVMM. I was running S2D and SCVMM in the DC, and it took 50 minutes. Oh, that's cool. It took only 50 minutes. So actually, I accidentally switched during the recording to this SCVMM DC machine, and it was still running. So this is pretty fresh. Let me just check if everything is okay. Some small error. Right, so this SR topology is not running. I have to validate why not. Maybe because 2019 changes, because I did it on nano servers, now I do it on the core servers. Maybe there's something wrong with that. So it looks quite okay. There's no red error actually, right? Looks fine. So let's take a look. Do we have two clusters? Probably yes. So let's take a look. Failover cluster manager. Let's full screen mode. This doesn't helping, right? So let's switch back a little bit. Go to failover cluster manager. Let's connect to cluster, browse, go to site 1 SR cluster, and now let's go to site 2 SR cluster, the second one. So as I said, we have two sites, one cluster in each. This scenario that I wrote, it's now 2 nodes, but it can be 3, 4, 16 nodes, whatever you want. In here, you will see that there are 2 VMs running, 2 nano servers, that because it's pretty small, not consuming almost anything, and it's still running. It doesn't consume any storage, right? I created 2 times 10 gigabyte disks, so on these disks you cannot place multiple core servers, because core server is like 6 gigabytes. This one is 700 megabytes, so it's pretty cool. I have disks. And if you'll take a look here, you can see the data 1 is online, while data 2 is without an access. Because data 1 is replicating to the other side, while data 2 is replicating from other side to here. So let's check the replication tab. And again, you can do you can do the very same in the Windows Admin Center and take a look how it looks like if you have a cluster with storage replica enabled. It's continuously replicating. You can see there's no access here. However, if you go to data 1, you can see that my disk is cluster storage data 1, and its log is located on log 1. Okay, that's cool. Okay, the second side is the same, but vice versa, because disks are replicating other way. And I'll also have some machines just to demonstrate. You can have like active cluster and just replicate to each other. So what happens? You may ask me, Jaromir, hey, how do I flip to the other side? How it will behave? That's why this one is actually combined scenario where I have a big scenario script, but I also have like a guide. So let's take a look on storage replica. There is S2D to S2D complex, and you can follow up the scenario, right? So for example, you would like to switch to other side, so you'll just go and say plant failover. So you will do some initial test, and the initial test is just if you are not running Virtual Machine Manager, because you don't want to run Virtual Machine Manager and say remove VM. Because removing VM in a Virtual Machine Manager commandlet, it means that you'll just delete all the files. In this case, I will delete only configuration because I'm using Hyper-V commandlet. So let me open up the PowerShell again. I can open up the new one, right? Or whatever you want. So let's keep this one open, and I will just right-click this script I just copied. Oh, that's terrible slow. However, what it will do is that it will, yeah, it's slow. Right. CPU is now 100%. Right. That's pretty slow. So, but you get an idea, right? How to flip it, and you would see that it will remove these VMs for cluster roles. It will stop these VMs. It will remove these VMs from Hyper-V, but before removing it, it will copy the VM files. It will remove the VMs. It will move the files back to the original destination, and then it will flush the disks into the flush the cache into the disks, because copy item is actually not write through, so it's not unbuffered copy, it's buffered. So you don't want to do buffered on replicated volume. VMs are doing unbuffered IOs, but if you do copy something like that, you really want to do flush the disks. Okay, it's now shutting down the VMs. Right, it shut down the VMs. It will, I'm not sure if what site I'm doing now. The source will be, I guess I'll be moving these in here, right? All right, it stopped. Now it will be removed. It will remove the roles. I guess the role is removed. It will flush the caches. After all of these machines are removed, it will also make sure that before removing the machine, I have backup location for the virtual machines config, and I'll just copy it back and remove it. I'll flip the replication, so now you should be able to see that data one disk will be destination volume. After that, we will be also able to see that the machines will be imported here and it will be running here. You can follow the guide. You can then flip it back, or you can then simulate unwanted situations like losing one side and how you can flip it, and then it's explained. It's explained in the scenario end to end. So this would be like a guided scenario, because I'm consuming a lot of CPU. Oh, I didn't wait here, right? So let's see what we did. Maybe you already added some node in the compute. Where's my nodes? No, or storage? Maybe storage. Okay, we did add storage node. So you can see now I have 5 nodes here. So this would be the way. So because my CPU is pretty utilized, let me just do one thing. I'll clean it up, because otherwise I guess we will not able to continue. Okay, running scripts, why not? Every cleanup script will ask you, hey, do you want to clean it up? And what you would like to clean it up. So don't worry, it will not wipe everything. It will just wipe everything that starts with your prefix. So it will go to lab config, take a look what's in the prefix, and it will and yeah, and it will list all the VMs which is on DC. And now let's remove it. Before I will hit enter, I'll just want to show you one thing. In my Hyper-V host, I have my DC here. It has a snapshot. So this snapshot happened even before I turned on the DC. So now I'll remove all the snapshots, checkpoints, and everything, and I will basically return to the state before turning on the DC, right? And also, um, you can see here that my lab here contains all the VMs. So this folder VMs will be just deleted after I remove all the VMs. And here, if I will remove the DC, it will delete these machines, these machine files, and it will restore it from the zip file here, right? So let's go. Let's remove everything. My CPU is going crazy, so I want to turn it off, remove everything, and I would like to, have my memory back. It's doing something, right? It feels better now. The memory is dropping. CPU will hopefully drop too. So memory is dropping a lot. CPU, well, it's dropping also. Cool. So I now have just my VMM1 and VMM2. So in VMM1, what we will do, oh, I forgot one scenario I wanted to show you. I wanted to add existing S2D cluster to SCVMM. So I guess now I would have to hydrate everything again. So I will not do this, but you can try by your own. Let me just log in. This is probably the first time I'm logging into the DC. I'll navigate into the GitHub page. I will go to slides. I will go to CDC Germany. And in CDC Germany, there are these scenarios, and there's SCVMM1. There's S2D and SCVMM in large data centers. I'll go to raw. I'll copy everything. You can put it into the PowerShell ISE, so you can just run PowerShell as admin. And then in PowerShell, you can run PowerShell ISE as admin. Let me just make this bigger so you see more. And from now, what I can do, I'll put here my script on the left. I'll just do it like this, and I'll Control M it, so it will be in regions. Now, actually, there are no regions, right? There are just function and everything. But let's do this, right? This scenario is more or less about how the virtual machine manager should look like. So what it will do now, it will start services. It will start service MS SQL Server and SCVMM service. It will import virtual machine manager module, and then it will connect to virtual machine manager server. It will start doing its magic. Before it will do its magic, I'll pause the script, right? So it will not do the magic before I will show you empty virtual machine manager. I'll open up the virtual machine manager console, connect to my virtual machine manager that is living on the same DC, right? And I will demonstrate there is nothing left. Not yet. There is nothing because it's fresh installation, right? Let me just pause it. I will have my virtual machine manager on left here, and what I will do, I will put my jobs window on the top right, so you can see what jobs are running. And you will hopefully trust me that it was empty. I hydrated it yesterday morning. Oh no, it was on the Tuesday. I had my session on Tuesday, so I hydrated this on the Tuesday, so it's pretty fresh. So you can see there's nothing, there's no host, there's nothing here, no host groups, nothing in networking, no logical networks, no logical switches. It's empty. It's vanilla environment. So you always start with vanilla environment. Let me unpause the script. Let me just wait. Let's see what jobs are here. Right now it generates some variables, so it will now create all the racks in Redmond, in Seattle, and now in London, right? So it is simulating 3 data centers. So you have you have 2 rooms in each data center. Each room has 2 ALs. Each AL has 4 racks. Ah, okay. What else is now happening? We are now creating logical networks, right? With IP pools and everything. So if I go to properties of the logical network, I'll have all the sites and all the networks in each site. So this will be probably, I don't know, rec 4. So imagine clicking this, it's impossible. So you have to figure out somehow how to create this infrastructure and how to design your data center. And as you can see, you can do it on your laptop without anything. It's super cheap if you are just using your laptop and Hyper-V, which is there available. Let's go and take a look in the logical switches. In logical switches, I'll go to properties, and I'll go to virtual ports and uplinks. Oh, there's no uplink. Right, I see it. I need to hit enter in this script because it's missing enter on this end, so now it will do all the uplinks. So I guess it will not happen like this. Maybe just go here and there. No, I'll have to open it again. So let me go to properties of the set switch. And in here you will see that each uplink port profile contains management NIC and 2 SMB NICs. And it's depending where you will have your server, the dependent uplink port profile will be selected, because this port profile is only for some location. In this case, it's in this site, which is in my case, this one is storage network, which is local to rack, and this is management network that's local to AL. So it's only available if you place your server into this location, right? So this is all purpose of this scenario, to demonstrate how the virtual machine manager can look like in the large data center. And here are also best practices. So you can see that RDMA NICs, which is VNIC actually, has classification that was created by the script. So if you go to classifications of the port profiles, you can see all these uplink port profiles that were created for every AL or every rack was created one. And also here you can see that there are VM NICs and VNICs. So VNICs are the ones that are visible by the management operating system, while VM NIC is the one that is visible by the VM. So this would be lab number 1. Let me show you lab number 2. Lab number 2 is bare metal deployment with Virtual Machine Manager, which is even more fun. It's pretty amazing how I like it, because it will demonstrate everyone how you can deploy your physical machine, and it will be doing everything in the laptop. Let's go to this, login into here. Let's go back to the WSLab. I will go to my CDC folder, to VMM2, there's bare metal demo, and I'll go to raw, copy everything, paste it into the PowerShell ISE. So I'll run PowerShell, I'll right click on the PowerShell icon, open up everything, I'll maximize this window. So we have something, I'll go like this, I'll go like that, I'll paste it here, and I'll collapse the regions with Ctrl+M. If I'll collapse all the regions, you can see what actually is happening. You can expand each region, study, and you can just run region by region and then watching the GUI what's happening. But let me just paste it, because I don't want this video to be more than 1.5 hours, I guess, because I'm already recording for some time, I guess. Now it's now validating if console is installed. If not, it will install it. It will ask you for setup file. So you can basically run this also from the management machine, which is Windows 10. From the original scenario, there's only differences that VDS server is not dedicated, WDS server is not dedicated. It's DC, the same machine as this one, but you can have also a different machine, right? Okay, so this will do all this configurations, configure the WDS. Next thing you will have to do is to create VMs, right? You will create a VMs on your physical machine. That's why there's a run from the Hyper-V host. I will have to switch to my Hyper-V host and run it from there. Oh, this is fancy. It will ask you for admin credentials. This will create runners accounts, so you can reuse the code the same as for your data centers. Corp /lab admin. If I'll mess it up, right, just type something, right, like this. It will ask you again. It's checking actually if the password is valid. So let me do this again. Corp /lab admin ls1 setup exclamation mark. I mess it up again. /lab admin ls1 setup exclamation mark. Now it's running. Cool. It will ask you for parent disk, so now I will choose core server because I want to deploy core servers. Let me just check one thing. Get the volume. I need to check if my volume still has any free space, right? Let me just do this. Right, I have found some free space, which is good. This is good. Let me wait a little bit. Okay. We have free space, which is good because you will deploy real operating system. It means I will create empty VMs and I'll then transfer into the empty VMs the VHD that will be provisioned in the virtual machine manager. So let's take a look in the virtual machine manager what's actually happening there. So I can again, it was vanilla environment. It was totally empty. Now what is happening is that it's being configured, and now I'm copying the VHD into the library. I'm configuring the VHD to be a Windows 7 because you need to add the tags. Right, so now it will start. So it may look complex, right? But you can see it's not complex when you reuse the scripts. Imagine these scripts not as a scripts but as a GUI, right? It's I'm just dragging dropping some pieces of the code, but after I will just expand the regions because you can copy it like that, right? Instead of clicking, you will just copy this and paste it there. But you have a lot of knobs. You have a lot of tweaks. You can tweak it. You can do everything you want. You can do all the small pieces. You don't like this and that, just do it different way. You need to optimize the code to run smoothly, to run faster. Just replace a piece of the code, right? You can do whatever you need. Okay, I should have in my library my VHG. So let me guide you a little bit through the environment. I should have a VHD in here, which should be 2019 G2. It's tagged as operating system 2016 Datacenter. Oh, it should be 2019. Let me just correct it. It's wrong in the code. 2000 Datacenter. Okay. And then there's VM template. No, VM template. Where is it? Hardware profile. Not yet. It's still being created. So now it will add the WDS to SCVMM. So let's take a look into the jobs. What's happening? It's adding Pixie server. So what it do? It will copy Windows PE into WDS. So this Windows PE will be booted. Okay. Let's take a look here. Is there anything yet? Pixie server, not yet. Let's take a look on networking. Let's talk about networking. So logical networks, the main problem with the logical network is that people do not understand it. Logical network is just a bunch of networks you would like to group together. In my case, I would like to group together our data center network and also VMs network. So data center network will be separate from everything else. In data center network, I have just two, so that's pretty simple. I have my management network and storage network, and these management and storage network are both available in the CLDC. You can add the VLANs and subnets. So management network is in VLAN 0, it's native one, while the storage network is in VLAN 3. There's a subnet and everything, so let's continue. Okay, looks like the first part finished, so we should see WDS7 in here. So it's here. We should also see in the library in the physical computer profile. Sorry, in physical computer profile you see Hyper-V host. In hardware configuration you will see that there's a GPT OS is right. It's NTFS here. No filter because it's not a real environment, but for real environments you will find it in the comments. You can uncomment a piece of code and add the filters and add it into here. There's domain name, admin password, which is same as the one that I specified. I just copied it. In the script you can uncomment some sections, a little bit modify, and then use your own. Time zone, AGS, no, this is not configured. We are not doing shielded VMs. So this is ready. Let's continue. Let's continue with other scripts. So there's a run from Hyper-V host part. So let me just copy, and then run from the Hyper-V host. The only thing you have to do before you run is modify your prefix if you have changed it, and also you have to modify your VMs path, because I'm creating the VMs in the same location as I do have my lab. Maybe it's your different drive or different folder, so you have to modify it. So I'll open up my PowerShell, some PowerShell, which is, let's say this one, and I'll create some VMs. So how it will look like in my physical host, it will create a VM and it will create some VHDs in the VM. So pretty simple script. Again, you can copy it and you can do whatever you want with that. You can create your own VMs, but remember, these are not domain joined. There's empty operating system. It's doing nothing. It will start. During the start, it will attempt to boot from Pixie server, and it will fail, right? So it will start Pixie, but it will be kicked out because WS didn't accept it, right? You'd find this information in the event log and the event viewer here. In the event viewer, you can see it, I think, under application services logs, right? It will be somewhere here, and it should be I'm here in Virtual Machine Manager, right? And server, in admin, or operational, one of these. Yeah, you can see here that Virtual Machine Manager will not deploy OS to computer, blah, 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 with MAC address, blah, 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 because GUID is not actually approved, right? As the machines are booting, it's here. So basically what I will do, I will grab all the information. I will just use the unique GUIDs, and I will just select all the time the only unique GUID from the two messages that are basically the same. I will grab the GUID and I will create a hash table. So if I'll continue in the script here, this region deploy hosts, I will actually create hash table like this, right? From the information from GUID. But in the real world, you can just uncomment this and use this hash table by yourself, right? You can fill your computer names, IP addresses, MAC addresses, GUIDs, and then you can just, run deployment. Whatever. So it looks like my machines are started. So let me run deploy host. Copy. And I'll paste it here. So it will create a deployment job. We should see it in the jobs here. Right. Let's take a look in the history. So now it's creating hosts. There's no BMC, right? So I have to reboot the host manually. You cannot do this from the GUI because there is no BMC, obviously. So now it's waiting to finish. So the next step would be to go turn off these VMs. The next step is to start it. Let me also connect it fast so we can see what's happening. It's starting to boot over Pixie. It will be approved. It will download the boot file that was transferred to the WDS, and it will start communicating. It will start booting the lightweight operating system that after it will boot, it will contact back the Virtual Machine Manager. It will receive information from Virtual Machine Manager that it should be deployed and how, right? Because all this information is specified. It will receive, by the way, it will also receive the IP address you want. because the script is doing DHCP reservations, right? So isn't let me know. I think this is pretty amazing, right? So let me know on Twitter, I'll retweet it, use it in your labs. If you want to use these labs as for your labs, for your trainings, if you are a trainer, just do it, right? I will be just happy, right? If you'll be tweeting about, I just used this lab in my sessions, it was awesome. I have already heard guys from Fujitsu that they are using it in their workshops. Right? It's pretty amazing, and I'm really happy about this. So I guess this would be it. We could sit here and watch how it works, but there's already one session on YouTube that I did before about all of this. So actually, then you would have to continue, and because the world is not simple, and our product also are not simple, sometimes complicated. There are some other scripts you have to run because some pieces are not in Virtual Machine Manager, I would say yet, like mapping PNX to VNX, or if you are specifying IP address that is already there, and if you want to make it static, it will hang. So there's not these small pieces, but the life is not simple, right? So everyone want to have like a single button deployment. If you think complex, if you don't want to have just solution that has everyone, if you want to have something unique, and I believe this uniqueness is what define your business or yourself, is what you are searching for, then this is stop searching anywhere else. Just use these scripts, modify it, and also expand it. If you have any ideas, pull me. Just add there. If you see some misconception, something wrong, let me know, right? If you want to write your own scenario, just do it, right? Uh, do it, push it there, or block whatever you like there's my scenario with this WSLab configuration file, and so on and so on. As I said, I hope you enjoy this session, um, and and in this session I would really like to say thanks to the Karsten who made all this conference possible, because it was amazing experience for me. I met so many nice people, MVPs, partners. It was just amazing. So I would guess have a nice day. I'll stop the recording now and see you on Twitter or somewhere.